Hello everyone. In the previous course, we have learned about basic ONDM management capabilities of GaussDB. In this course, we'll focus on GaussDB, backup and restoration capabilities, including the basic principles, best practices, and ONDM operations on GaussDB management platform. In this course, we'll talk about the GaussDB, backup, and restoration principles, procedure on GaussDB management platform, as well as scenario-specific fault locating methods and handling policies. First, let's talk about the basic principles of backup and restoration. Databases feature high reliability and availability. Why is backup so necessary? Backup functions in the following aspects. Firstly, preventing misoperations. If a database or table is maliciously or mistakenly deleted, data on the standby nodes is also deleted and cannot be restored. With database backups, deleted data can be restored to improve data security. Secondly, highly reliable redundancy. The data of your database instances is backed up to multiple storage media, such as OBS and NAS. So data reliability can be ensured even when there are hardware faults or natural disasters. GaussDB provides cluster-level and table-level physical backup based on the OBS, NAS, or disk, as well as cluster-level and table-level restoration for homogeneous databases with the same number of shards and major version number. Now, let's talk about the similarities and differences between full backups and incremental backups. In a full backup, all of the data from a specific point in time is backed up. You can use a full backup to restore a complete database. The time required for a full backup depends on how much data there is. All of the data is backed up, even if no data has been updated since the last backup. In an incremental backup, also known as a differential backup, only data that has changed after a specified point in time is backed up. It takes less time than a full backup. The time required for an incremental backup depends on how much data has changed. The total data volume of the database is not relevant. An incremental backup cannot be used to restore all of the data of a database. That is to say, an incremental backup is always based on a full backup. An incremental backup cannot be performed based on the full backup that has been used for a full restoration. To perform an incremental backup after the full restoration, perform a new full backup first. The following uses a full backup as an example to describe how to backup data. A full backup involves two types of files: global data files and incremental logs up to a certain point. As we can see in the figure, there are two tables, and different DML statements are being executed. The lines indicate the progress of LSN logs, and the small blocks indicate the data files. If you copy a data file during the backup task execution, the transactions in the data file may not be completely modified, causing consistency problems. All target data is recorded in the logs of a database. You can obtain data files, as well as the execution locations in the logs, and replay the data files and log files to execute the restoration process. Now, let's look at the incremental backup process. As we know, a reference point is required to serve as the basis for starting an incremental backup. During an incremental backup, only incremental data is copied. In the kernel, there is an asynchronous thread, which records the pages where data is modified. In this way, during an incremental backup, you can access the combined pages recorded by the asynchronous thread to obtain information on the modified, truncated, or created pages. Now, let's talk about the concept of point-in-time recovery (PITR). We have learned that full backups and incremental backups have specific time points. PITR can use backup sets and archive logs to restore instances to any point in time. PITR can be used to restore an instance to the time before a serious mistake is made. In this figure, baseline backups and archive logs are used as restoration files, based on which we can use PITR to restore a DB instance to any point in time. Let's have a look at this figure. If an error occurs at 12, for example, all tables are deleted by mistake, you can set the target recovery time to 15 to 12 and perform PITR to restore the database to its status from before the error. Next, let's talk about how to backup and restore data on GaussDB management platform. First, let's talk about how to perform a backup. You can perform either an automated backup or a manual backup. Automated backups are created during the backup time window of your GaussDB instances. The system saves these backups based on a specified backup retention period. If necessary, you can restore data to any point in time during the backup retention period. In addition, after CNS or shards are added, the system will perform an automated backup. Manual backups are user-initiated full backups of instances. They are retained until you delete them manually. You can log into GaussDB management platform and create a backup plan. To execute a backup task, the procedure is as follows. Log into GaussDB management platform. Choose Instances in the navigation pane. Click the name of the instance to be viewed. To switch to the Details page, in the navigation pane, choose Backups. All created backups are displayed in the right pane. Perform corresponding operations based on the task. To perform a manual backup, click Create Backup. In the displayed dialog box, set required parameters, and click OK. It is recommended that a backup name and description be configured, so you can identify different backups easier. For a manual backup, you can specify the backup scope. For example, perform a table backup. Have a look at this figure. Click Create Backup, set backup parameters, and click OK. Select the tables to be backed up. Click OK. Different from manual backups, you need to create a backup policy before enabling an automated backup. Then, the management platform starts the backup task. Based on the created backup policy, the configuration operations are as follows. Firstly, set an automated full backup policy. Secondly, click Modify Backup Policy. Thirdly, set backup parameters and click OK. Set a backup policy as prompted. Refer to the following backup-related configurations. Firstly, differential backup. Set the interval for performing a differential backup. In minutes, the value can be 15, 30, 60, 180, 360, 720, or 1,440. Secondly, retention cycle. Select any combination of days. Within a week, at least 1 day. Thirdly, time window. Set a time period to start an automated backup. Fourthly, backup flow control. Set the upload speed when backing up data. And prefetch pages. Set the number of pages to be prefetched from the modified pages in the disk table file during a differential backup. Similar to manual backups, you can also specify the backup scope for an automated backup. For example, perform a table backup, as shown in this figure. Click Modify Backup Policy. In the displayed dialog box, set backup parameters and click OK. Set a backup policy as prompted. After the backup is complete, you can view and delete backup records and restore instances on the Backups page. The procedure is as follows. Firstly, on the Instances page, choose Backups. Secondly, click the Full Backups tab to display all full backups of instances on GaussDB management platform. Thirdly, click the Differential Backups tab to display all differential backups of instances on GaussDB management platform. You can perform a restoration task based on an existing backup set, as shown in the figure. Access the backup management page. Click Restore in the row containing the target backup record. In the Restore DB instance dialog box, set restoration method to restore to original. This operation will overwrite the data on the original instance and cause the instance to be unavailable during the restoration. Click Next. You can also set restoration method to create new instance and perform operations as prompted in the figure. You can also restore data from a table. The procedure is as follows. Click Restore in the row containing the target backup record. In the Restore Table Backup dialog box, set restoration method to restore to original. This operation will overwrite the data on the original instance and cause the instance to be unavailable during the restoration. Select the tables and click OK to execute the restoration. Now, let's move on to the PITR restoration process. First, log in to GaussDB management platform. Second, on the Instances page, click the name of the target instance to go to the Instance Details page. Third, in the navigation pane, choose Backups. The Full Backups tab page is displayed by default. Fourth, click Restore to point in time. Fifth, in the displayed dialog box, set Restore to time range and time point. Sixth, set restoration method to create new instance. A. If you set restore data from to instance, enter necessary information for creating an instance. B. If you set restore data from to databases or tables, select the databases or tables to be restored on the Create New Instance page. C. The restoration restrictions are as follows. The database version, architecture type, OS, and type of the new DB instance must be the same as those of the original DB instance. The number of shards of the original and new instances must be the same. For instance, only a to-node primary standby instance can be restored to a new primary standby instance with 2 nodes. D. Ensure that the specifications and storage space of the selected host are greater than or equal to those of the original DB instance, and a new database password is configured. Seventh, set restoration method to restore to original and deliver a PITR restoration task. Next, click OK. Then, view the restoration results. This step is optional. If Create New Instance is selected, a new DB instance is created using the backup data. The status of the new instance changes from creating to available. If Restore to Original is selected, after the restoration is complete, the status of the instance changes from restoring to available. You can restore data from a table using PITR. The procedure is as follows. Log in to GaussDB management platform. On the Instances page, click the name of the target instance to go to the Instance Details page. Choose Backups, then Table Backup. Click Restore to point in time. For restoration method, you can select Create New Instance or Restore to Existing. Select the restoration date and time range, and enter a point in time. Set restoration method to create new instance. On the displayed page, configure the databases and tables to be restored. For details about the parameters required for creating an instance, see the operations related to creating a DB-mined instance. Set restoration method to restore to original, and select a database and table. Set restoration method to create new instance. On the displayed page, configure the databases and tables to be restored. For details about the parameters required for creating an instance, see the operations related to creating a DB-mined instance. Click Apply Now, and then execute the restoration task. For backup sets, you can either manually delete a manual backup on the Backups page, or set the backup retention days in the Modified Backup Policy dialog box. Expired data backups will be automatically deleted based on the backup policy. Refer to the operations in the figures. Next, let's talk about the troubleshooting process when performing a backup. If a fault occurs on the management and control plane, an error message is displayed in the task center. If the information cannot be used to locate and demarcate the fault, view background logs. The process is as follows. Firstly, log into the console and obtain the ID of the node where the backup task is delivered. Secondly, log into the node as the database installation user. For example, Ruby, go to Home Ruby log request, agent log, and find logs of a specified time range, and the IP address of the node where backup forwarding is performed by searching for send backup request. Generally, the IP address is that of the first CN node. Thirdly, log in to the backup forwarding node queried in step 2, the primary node, for kernel backup, and open the log file generated in the Gauss log roach controller directory at the corresponding point in time, and search for the first error log generated after the backup identified by the PID starts. If no log is found, open Home Ruby log agent log and check whether an error is reported at the corresponding point in time. Fourthly, if the error message pull subprocess ret code abnormal is displayed in step 3, the GS roach process failed to be executed, open the log file generated in the Gauss log roach agent directory of the primary node at the corresponding point in time, and search for the first error log generated after the backup identified by the PID starts. If information similar to master operation failed in agent, please refer the corresponding agent logs for more details is displayed. There was an error on the GS roach process of the node. In this case, go to step 5 and log in to the SPICIF node to locate the fault. Otherwise, the backup error was on the current node. Locate the fault based on the error information. At last, log in to the SPICIF node obtained in step 4. Open the log file generated in the Gauss log roach agent directory at the corresponding point in time. You can use the PID to search for the first error log after the backup starts, and locate and rectify the fault based on the information provided. After obtaining required error logs, rectify the fault by following the instructions provided in section 7.2.11 Troubleshooting in Administrator Guide. For example, a backup fails even though the buffer size value and the number of parallel processes are within an acceptable range. Cause: the buffer may be too small. If the memory is full or has limited space for the specified buffer size, the backup fails. Solution: check the available memory and reset the buffer size to a value smaller than the available internal memory. That's all for today. In today's course, we learned about the backup functions, types, and principles for GaussDB instances, how to modify a backup policy, and how to restore DB instances using backups. Thank you for watching. Stay tuned for our subsequent courses.